Hi, I'm Dylan, and today I'm going to be going over mine, Vincent's, and Jackson's CISC190 Java Programming Final Project. For our final project, we decided to do the Advanced Collage project. And over here in BlueJ, you can see a bunch of different classes that relate to the collage project, but today I'll only be going over the main and picture class since those are the only two that we really modified. Over here at the top, we have a bunch of different packages that we imported from Oracle's Java website. What these do, they allow for us to utilize stuff like scanner, file chooser, and all that allow for user input. So the users are able to use our software. Right below this, we have the public class main, which extends the picture, and then the void main string, which allows us to essentially run the entire thing. First line of code here is scanner, which allows for user input, which will then ask the user, which template do you want to use, and please select a number below. And this ranges from 1 to 3, with 1 being horizontal collage, 2 being vertical collage, and 3 being advanced collage. And these answers will be saved as an integer for the system to read. So here it's going to ask to pick your first image, and this is where the user this is where the system will open a file chooser for the user to choose what image they want to select to add to the collage. And this here sets a height boundary to 300 for the image. And over here is filter chooser, which I'll go into the picture class later to explain. And then it'll repeat for the next two questions when it'll ask pick your second and pick your third image, which will set the same height boundary. And down here, it'll just explain if you pick 1, 2, or 3 for your collage. If it'll give you an if statement where if you pick 1, it'll give you collage horizontal. If you pick 2, it'll give you vertical collage, and if you pick 3, it'll give you collage template or advanced collage. Or sorry, no, I was right. Okay, advanced collage. Right below this, we have the public static void collage horizontal, which this handles the horizontal collage, which sets the pictures in a horizontal manner, which sets them next to each other. And this includes the 3 previously mentioned pictures, 1, 2, and 3, and adds them together with the added width of 300 to each side. This only uses just basic integers using added width and set height, so it's nothing too hard. The one below the method below is a bit harder, but it's not too bad. Here it sets a name for pick 2 and 3 and makes a copy of pick 2 and 3, and this over here scales the width and height of pick 2 and does the same for pick 3. And down here it sets the height and width of the template to make sure we don't get any ugly white borders that shouldn't be shown. And down here runs the actual collage, which is the final thing that the user will see. Down here is the advanced collage, which what it does is it sets up the width for the third template. The inth for the width too. It sets up the width for the third template. Down here, these 2 lines of code run to make 2 formulas to scale the width and height for the bottom image. This line of code scales the bottom image to the correct width and height, and the one below this creates the height for the third template. And this one runs the third collage with the new method, and this will create the final product the user will see for advanced collage. Now, probably the most important part of this project, aside from putting the images together, is the different filters and attributes that we've added to the user's photo. So up here we have more packages that we imported from Oracle's Java website, and here we have the public class picture, which extends to the simple picture. And this essentially just declares picture as a subclass of simple picture. Here we have a bunch of constructors: super file name, super width and height, super copy picture, super image, things that are just explained in simple image and that are used here. Here we have 2 strings. What this line of code does, it starts building a description string, it adds the picture's height and then the picture's width and returns the final string. Here's the main method, and it's run when executing pictures of program. It opens a file chooser, returns the path of a selected file, and Below that, the picture picked obj creates a picture object from that file. And below that, the Picture Explorer opens a viewer window to display/explore the image for the user. So here we have collage 1, which I think, let me check just so I don't give you wrong. Yes, horizontal collage. This is what handles essentially most of the work for making sure none of the boundaries go out of place, making sure that the image can get modified by the different filters and all that. Up here we have the pixel source pixel and pixel target pixel, and what this does, it holds a pixel read from one of the source pictures, and below that this holds a picture holds a pixel in this picture or the destination, and below this is the integer pic2end, which has the x coordinate where pic3 begins after pictures 1 and 2. Here we have these lines of code which allows the images to be modified by the different filters by using source and target pixels to target which pixels we want to be modified by the code. Aside from, sorry, I had a small brain fart. Aside from collage, why are they called collage 1, 3? Why are they out of order? Whatever, it doesn't matter. So collage 1's horizontal. I'm guessing this is advanced collage, and this is vertical. They seem to be out of place, but I don't think it makes a difference, at least not when we run the code. This is essentially the same thing that's used by all three of them, just with minor differences. But down here is where the actual filters start to get added. So here we have the public static void filter chooser, which allows us to select how we would like to modify the images that we get from file chooser. So here we have scanner, which creates a scanner to read user input from the keyboard. And below that, it prints out what filters do you want to use. Please select a number, which is the prompt message. And it'll give you up to 10 options. We would have included more, but we felt that having 10 was already pretty overkill. First one is 0, which gives you no filter, which should be self-explanatory. It just does nothing aside from creating just a simple collage with the 3 images. Next, we have mirror horizontal, which mirrors the 3 images you choose horizontally. And below that, we have mirror vertical, which mirrors the 3 images vertical this time. The third option is inverted, technically the fourth option is inverted, which inverts the color of the image that you choose. And below we have, for option 4, 5, 6, 7, 8, and 9, we have different colored filters that change the colors of the images you want to choose. So it can make them red, orange, yellow, or red, 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 or just any kind of variation you want to choose depending on how you want it. And then finally we have grayscale, which converts your image into like a noir, black and white sort of image, which is, I'd say, pretty cool. Over here we have integer filter, which is for filter, which allows the system to read this different inputs you select. Like if you choose 0, it'll put out 0, and it'll assign it over here to the if statements. If you put 0, it'll give you the no filter selected image. Otherwise, if you put 1 to 10, it'll give you any of the corresponding filters that have been created. So say if the user chooses 0, it'll print the no changes made. If the user chooses 1, it'll apply mirror horizontal to the picture passed into it. And same with apply mirror vertical and the rest below it. If the user were to type something else, say 11 or anything like that, it'll return the same, I guess it'll return the same sort of, that's interesting. In theory, it'll probably return no filter selected, but it also might not print out anything, but it'll probably have the same outcome as filter 0. So down here is where we have the different filters, or where we created them. Here's mirror horizontal. This first line of code, it gets the image height and stores it into height. And below that we have integer mirror point, which takes the height and divide it by 2. And below that, we have the pixel top pixel equals null and pixel bottom pixel equals null, which takes a pixel from the top half and takes a pixel from the bottom half and allows them to be modified by the code below. Here we have two for statements or for loops that loop over every column for the first for loop, and for the second one we have it loop over the half rows only, which gives it the effect this code down here gives it its effect. This just states where it wants it to loop over. It's essentially the same over here with mirror vertical, just technically the opposite since it's doing it in the other direction. Here we have inverted, which inverts the colors. This is done by getting the current pixel color and it'll read the red channel, the green channel, the blue channel, and what it'll do is it'll invert the red, green, and blue colors to what they currently are at and change it to whatever its corresponding opposite value on the color wheel is. Down here we just have an index which moves pixel to pixel until it inevitably runs out on the image. Here is where we have the different colored filters. Over here we have red, orange, yellow, green, blue, purple, and what essentially these all have in common, what they do is just subtract and add colors, or they subtract, add, multiply different color values to get the image's end looking color. I'll take orange as an example. Here we have pixel array, which gets all the pixels. Pixel p equals pixel null is just a pixel placeholder, and we have the index or integer set to 0 just for it as an index counter. Down here we have a while loop, which loops all the pixels, and pixel array down here goes to the current pixel. And these three lines of code, what it'll do, it'll take the average intensity of the colors, and what it'll do is be affected by these two lines of code down here, which scale the existing green channel and the existing blue channel and modify it to make the colors look orange instead of the different colors of the RGB spectrum. The final filter we have is grayscale, which what it does is it essentially takes all the colors and converts it to the closest shade of black, gray, and white. This is done by the same as the other color filters for the first initial lines of code, by getting the pixels, getting a pixel placeholder, and a counter for index. And this time we have another while loop, which will loop all the pixels, and then we'll use another pixel array to get the current pixel. However, what this will do, it'll take the average intensity of all the colors and set them to an average value, which is the different shades of black, gray, and white, whatever the closest equivalent intensity value would be for the color. And here is just an index, which will go pixel by pixel until it inevitably runs out. So I will demonstrate what the code does right here by running void main string. I'll just go with advanced collage, and this will prompt me to pick my image. So I will take about this Weezer PNG. What filters do you want to use? I will pick inverted. As you can see, it prints pretty fried photo, but that's what we want. I'll go to school and look for the different images that, okay, and here I have, I'll take banana. I'll convert it to grayscale so it comes out as black and white. As you can see, it made the image black and white instead of what it was originally, which was yellow, orange, and all the original shades that it was. I will go down here to download where my different images are and go to, let's pick a fun one. I'll get Senator Armstrong from Metal Gear Rising, and I will make him, let's say, red. And there you go. So you can see that the three images have been thrown together, And you have your first image up here, which has the inverted color, the second image here, which has grayscale, and the third image, which has had all the pixels set to some different shade of red based on its original intensity. And as far as I could tell, I think we did a pretty good job of avoiding any white borders. Just ensure that the code isn't image specific. I will run the program again just to make sure, the other collages are also working, like vertical, for example. So I will go back to school I'll go to school over here in downloads, click on the folder, and go to, let me look for a different image. PDF. I'll just take a random file that I did for one of my other classes. Here I will apply the orange filter. There you go, just some basic math for whatever I was using that for. Go back to school. Look for, what's another good PNG I could use? Is stupid meme I use for one of my other collage projects in this class. I will use, let's say, green for right now. And just one more image. And come on, I gotta have another one. Here you go, Filipino flag. And I will use, this time, no filter. And bam. This creates a very stretched and messed up 3 images for the vertical collage. And as far as I could tell, I think that's it for this project. Some things I wanted to add that we didn't get time, we had time, but we thought for the sake of simplicity and not overcomplicating things and creating more possible errors, I was working on a GUI for, I'd say, half the project, but we decided to just go through with the GUI, with Scanner, and just modify that to make it as simple as possible. Otherwise, yeah, I thought this project was extremely interesting. I had a lot of fun with it. It was super cool collaborating with my friends on a project. And I do wish we had more time. I feel like we could have really fleshed it out, but at the end of the day, this isn't meant to be like something like super brutal or like soul crushing, so it's all right. Thank you for watching my video, and hope you have a great rest of your day.